All right, so last time we did a review of fractions. We reviewed PEMDAS, order of operations, talked about signs, when is it negative, when is it positive, how to add and subtract, multiply with negative numbers, and now we talked about LCD. So that's what we did last time. So now we're going to actually begin the material for chapter 1 that your homework's based on. We started a little bit, but not too much. But let's go ahead and start here. So I'm going to redo the question from where we left off. All right, so this is chapter 1. Turn on the light. Chapter 1, algebraic expressions. Okay, so this is we're working out of your workbook. So this is example 3 on chapter 1. So this is where we left off. We said this is the Fahrenheit formula, 9/5 C plus 32. And I said if you're given a Celsius, you can convert it into Fahrenheit just by plugging it in. But the point of the question is just to be comfortable practicing plugging in things into variables and the order of operations. Okay, so we're going to plug this guy into wherever you have a C. So F will equal 9/5 times negative 25 plus 32. So all I did was input C equals negative 25. Okay, so following the order of operations, we know we should do the multiplication first. It's always left to right. So we're not going to mess with the plus until we're done with this. Now, last time we said you can multiply straight across and treat them as fractions. So this is as if you have a negative 25 over 1. Okay, so just multiply straight across, but remember when we were doing fractions, we said, don't actually multiply it out, just put them right next to each other and see if you can reduce the fraction. Okay, so this is negative 9 times negative 25. And we said if negative times negative is going to be, let's see here. We said it's going to be positive, right? So in the next step, I'm not even going to write the minus anymore. So assume these will become positive and start reducing your numbers here. So this would be 3 times 3 for 9. This would be 5 times 5. You don't really have to go that far to break them down, but if you're not used to reducing fractions, doing it this way, you'll never miss a factor. So this will cancel one of them and one there. 5 divided by 5 is a 1, so they're gone. So they're canceling out, they're not zeroing out. Some people think that that's a 0. If you divide by the same thing, it becomes a 1. So they leave a 1. So 3 times 3 is 9 over the 1, which is basically 9. Oops, oh, I missed a 5, didn't I? It looked too small for me.
Wouldn't the answer be 45?
Yeah, 45, there you go. It'll be degrees Fahrenheit, right? Anyway, any steps that don't make sense. And the point is, can you plug in a number? Can you multiply fractions? Are you comfortable with signs? And are you comfortable reducing? So these are things we reviewed. So now we're actually going to use it to solve a problem. Any issues with number 3? Does it make sense or is it weird? Okay, so let's do one more that's similar and then we'll move on to something else. Okay, so this is example 4 in your workbook, page 7. I'm gonna try to put the number here in case you want to look it up later. Look at the problem. They don't have the solutions though, but here they are, right? Okay, so t is equal to, there's another equation here, a formula, 2.0 times pi times the square root of L over 9.8. Now, pi is equal to 3.14. L is equal to 0.8 meters. So all they want you to do, so they give you a weird looking formula here. All they want you to do is plug in the pi rounded to 314 and L, and then simplify. That's what they want you to do. Okay. So here we go. So t will equal 2.0 times 3.14 times, I'll make this a little bigger, 0.8 over 9.8. Okay. So at this point, I would recommend using your calculator just because 2 times, this one will be pretty easy, but in here, I don't really care for dividing decimals. So then you are allowed a basic scientific. So what is 2 times 3.14?
Want to be 6.14?
6 is close. You got to double the 1.4 as well. Be 6 and
6.28.
yeah, there you go. 6.28. All right, so you can do this entire thing in your calculator if you like. Let me find my, actually, give me a moment. I'm going to grab the calculator that's recommended for this class so you can see how it works. That way, in case you got one or check one out. Give me one moment. All right, this is the one that they want us to use. I think I've had this in my car for like a few years, but let's see. Turn the light on, you can see it better. All right, so hit simply the second x squared button to create a square root there. Plug in the 0.8. Actually, you can press a button that creates fractions. Let's see. There we go. You can press a fraction button and plug in 0.8 on top, 9.8 on bottom. Okay. Multiply this by 6.28. And we can round to 2 decimal places. That's what the question said. So we should be at, once you start rounding or using your calculator, use the symbol for approximation. It's going to be 1.79. Now you could have done these long division for this, but you'd have to screw with a weird number anyway. So I recommend you use the TI-30 for those types. But anyway, is there any questions on the actual plugging in the numbers and what goes first, right? We did the square root first, and then you multiply by the results over here. I'm going to plug in the result of the square root here. Anyway, we'll move on to another topic. Is there any questions on example 3 or 4? Is it okay? All right. So the next part, let me write it down for you. It says determine the numerical coefficient of the indicated term. So basically, they're going to tell you, oh, what is the coefficient of this term or that term? That's all they're going to do. So example 5a, they give us a few terms, and they're going to ask us what is the coefficient of the first term. So I'm going to say coefficient of first term. All right, so coefficient, all that means is what is the number in front of the variable. So the first term is right here. So all you have to write would be the number in front. That's it. Don't write the entire thing, just the number. So the answer would be negative 0.3. Right, nothing crazy. So they just want you to know, they want to know if you know what a coefficient is. So let's look at these together. So look at part B. What is the coefficient of the second term? What do you guys think? Right, so it's going to be first and then second. So you would just write the number, right? So you would write on your paper just 4.2. Over here, you have 1, 2, 3 terms. Remember what we said last time, what is a term? Term is must be separated by a plus or a minus. So 14x is one term, is the first term. 17y here is the second term. 6 is the third term. So the coefficient of the second term is the negative 17 here. Okay. So as long as you know what a term is, you should be able to find the coefficient, no problem. 1, 2, 3 terms. You would say -1 here. No, does that make sense? Is there any question as to what is a coefficient? Is that straightforward, or is there something missing? I'm going to assume you guys are good. I'm going to move on then. Just let me know.
Wait, so in example 5F.
5F?
Yeah.
Yeah, that's a good one, actually. If you look at it, this is one single term, right? Because there's no pluses or minuses in between.
Yeah.
But there's a number on top and there's a number on bottom. So the coefficient would actually be -7/8. So that's your fraction. It's like a fraction in front. So you pull out the entire thing out. That's a good question. Any other questions?
No, sorry, they were good.
Okay. All right, let me know. We can revisit that if you have any issues. No big deal. All right, let's see here. All right, one moment. All right, sorry about that. Okay, so number 6. So this section here, page 8, is all about combining like terms. So simplify if you can. These first 6 through 10, they just want you to check it and see, okay, is there anything that combines, adds together, subtracts, that type of stuff. 11 and 12, they want us to actually multiply because you have parentheses. So let's go through most of these. Let's do number 6. You guys cool on this page I just turned? Okay if I turn the page? Right, let me know. I'll turn back if you need it. If you miss something. All right, so example, so all the problems will be the same. Simplify the following. Three x squared plus 4x squared. So notice how they have the same type of x with the same type of power, right? So since they are the same, this is like saying 3 apples plus 4 apples. It doesn't really matter what that is, right? 3 squares plus 4 squares. 3 triangles plus 4 triangles. Since they are the same, you just combine the terms. Don't let the variables bother you. So all you're going to do is add them together, right? 3 plus 4 is 7. So nothing happens to the power. So you had three of those type and 4 of those type. Now you have 7 of them. Is there any questions about combining like terms? This next one, you can see that they're not the same, right? You have an x squared type and then you have a y. They're completely different. So this is when you cannot do anything. So don't force it. When you're doing your homework or you're on a test, don't be like, oh, this has to be a 7. Like, no, just relax. It's not going to be anything because these are different things, right? You cannot add apples and oranges. This is what they mean, right? You can't combine them. So that's it. There's nothing to do here. You would just write the same thing. Does that make sense?
Yes.
All right, let's move on to another one. Can't combine. Not like terms. Looks like I wrote cat. Sorry about that. Okay, number 8. This is all from page 8. In case you want to look it over. Negative 3x plus 5 plus 7x minus 3. Okay. So you notice that there's 2 constants, right? They're both just regular numbers. So for sure you can combine those together, right? Now, these 2 are the same type of x, they just have different numbers. So you can also combine those. So what I recommend usually is just to write them together. You know, I'll write it one more time. just group the stuff that is the same before you do anything. That way you won't mess anything up. And again, I'm not going to make you do anything. All I want to see is your steps and correct math, and you'll be good. But I'm giving you recommendations. Put them together like this will make it easier. So now we just do the rules of signs, right?
4x plus 5 minus 3.
Oh, you're talking about the solution, -3 minus +7?
Yeah, wouldn't that turn into 4x?
It is going to be a 4, but is it going to be positive or negative? What was the rule?
Doesn't it stay positive because the 7 is positive?
Yeah, the 7's bigger, right? So the rule says if you keep the sign of the bigger one. So 3 minus 7 is 4, positive. Right? Or 7 minus 3 is 4, positive. Yeah, you're right. So that's this one. Okay, so now we have two numbers. 5 minus 3, no big deal, right? Any questions on those steps? You see, we only combine the ones that were the same. Okay, let's move on to something else then. Unless you have some questions on like terms. You guys okay? No, let me know if you feel confused by anything, right? It's not a big deal. That's what you're here for. All right, so on these type, it's still technically simplifying. So we will simplify by distributing the 7. Over here, we were simplifying by combining like terms. So it's a different operation, but still simplification. So when we have parentheses and a number in front, we have to distribute the 7 into both terms. So 7 times 3x plus 7 times 5. So I put the 7 on both pieces, right? 7 times 3 is 21. It doesn't change the x. 7 times 5 is 35. If you feel comfortable going from here to here, that's fine. Just be careful. Is there any questions on the distribution? Okay. Let's do another one. 2x minus 4y plus 5 times 5. So now the numbers on the back, but it is no different from this. We're just going to be distributing this way. And if you want to, you could put it in front. Like if, let's suppose this really bothers you, you could say this. That's okay too. It doesn't matter where it is. You need to multiply it out. Right, so multiply 5 on each of these 3 terms. So whenever you're distributing, it happens over separate terms, right? Don't forget what is a term, right? That's why it's important. Minus and the plus separate the terms. So let's show the work. 5 times 2. 2x is positive, so it'll be just 2x. I'm going to put minus. So this step is up to you. So you could put You can just separate them all by plus to make it simple and put the minus inside here. Do you see what I mean? I'm separating them all by plus and putting a minus there. You could have put the minus there, but I think it might be safer to just put pluses everywhere and just keep these signs inside. This was positive, kept it positive. This was positive, positive. Okay. Now it's up to you. I'm just giving you advice. So now we can just straight up multiply and deal with the signs now. 5 times 2 is positive. So nothing weird. Positive 5 times negative 4 will be negative 5 times 5. Is there any questions on any of the steps? Okay. Let's move on to a different topic then. So we did like terms and distribution. So let's do some more complicated distribution that will deal with signs and variables. So right now all we did was some basic numbers, right? 7 and 5. Okay, one moment. Okay. So still simplifying the following. So negative 4 times negative 3x plus 6 minus 2y. So just distribute the negative 4 on each piece. So this negative is going to switch the signs inside to the opposite. It's going to swap them. So if we do it the way we were doing earlier, we can write it this way. That way we won't mess up the signs. So negative 4 times negative 3x, negative 4 times the 6, negative 4 times negative 2y. So negative 4 times negative 3. Negative 4 times 6. So negative is positive, right? 12. Negative 4 times a positive 6 will be negative. Negative 4 times negative 2 will be positive. So just be very careful as soon as you see a distribution problem with a minus, I recommend for sure do it this way so you can be careful. Okay. Is there any questions on distributing negative numbers? Okay, let's try one that's really ugly. And then we'll do one with fractions and we'll move on to chapter 2. All right, one moment. I'll let you. Oh, wait, before I turn the page. Okay. This one will have a lot of multiplying or distributions. Let me try to be as neat as possible here. Example 16. So y times 3y minus 8 minus 2 times y squared plus 6 plus 3 open parentheses 2 open brackets 5y minus 4 close brackets minus 6 parentheses. Okay, so this one's kind of disturbing looking. It's not pretty at all, right? But this will test our rules of operations, right? PEMDAS. And it'll make us practice the distributions, signs, all at the same time. So that's a good question. It's just not a pretty one. So we'll go left to right, but I'm going to work with this because it has the innermost parentheses, right? That was the rule. To work inside here and work your way out, and then we'll go left to right. So I'm not going to mess with this first part. You technically could. It wouldn't mess it up, but let's follow the rules for now. Okay, so inside I have a distribution, so 2 times these two pieces. So I'm gonna have 2 times 5, which is a 10. 2 times a negative 4. So that result comes out, and I still have a minus 6 right there. Okay. Okay. Now we can technically combine these and work inside those parentheses. Let's go ahead and do that. Show extra steps just in case. So negative 8 minus 6. They're both the same sign, right?
Want to be negative 14?
Yeah, negative 14. So now everything's good inside, right? So let's go ahead and distribute left to right. So multiplication comes next on the priority. So distribute the y, distribute the negative 2, and 3. So I'm going to show the actual step here. Y times 3y plus y times negative 8. If you want, you can put this in parentheses too. That looks a little messy. Let me fix that. I don't usually put them in parentheses unless there's a negative on it. But for consistency, y times -8 minus 2. So this will be plus -2 times y squared plus -2 times 6 plus 3 times 10y plus 3 times -14. Ran out of space. I'm sorry about that. All right, so y times 3y. What is that going to be? Do you remember your rules of exponents?
Wouldn't it be 3y squared?
Yeah, it'll be 3y squared. So you only multiply the y's, right? That's it. The next one, y times -8. Well, that's just -8y. This is the same type of deal. -2 times 6. 3 times 10. 3 times -14. What is 3 times -14? It's negative, right? Is that -52? Or 42? What do you guys think?
It's -42.
42. That's right. Okay. So at this point, they're all multiplied. Everything has been distributed. We're good. So let's put everything that is the same, has the same type of exponent, same type of variable, just next to each other. And then we'll combine like terms if we have any. So I see a square and a square. I see a y and another y. And I see two constants, the 12 and the 42. Oops, kind of fell off the line there. Okay. So let's start combining like terms, right? 3 minus 2.
Wouldn't that be y squared?
Yeah, just a single, right? You could put 1 if you want to. Some people do, but it's not wrong. Most people just don't write a number. It's implied that it's a single y squared. -8 plus 30.
Wouldn't that be 22y?
20, yeah, that sounds right. 22y. Negative and negative that's subtracted will stay negative.
Wouldn't it be -54?
-54. Yeah. Now, is there any questions about why this became y squared? Or about the distributions? Or why we did this first inside here? Or any question at all? All right. Let's do one with fractions and then we'll move on to chapter 2, assuming there's still time. I have no idea what time it is. Let's check in a second.
$106.
106. Thanks. Again, all of these problems are simplified. We're not solving for anything. We're just simplifying and doing operations. Okay. So this one is the same stuff we've been doing, but now that we have fractions, they may feel difficult. But it's not any different. So let's go ahead and distribute. Remember I said just put it in parentheses times the first term plus, again, 2/3 times the second term. So that first part is done. And we decide we're just going to separate everything by plus and leave the signs inside the parentheses. Just to make it simple. So the first term, second term, plus. Okay. I'm going to do the same with these, of course. Now, remember, there's technically always a 1 underneath, right? Always a 1 down there. So you're going to multiply straight across. Once we've done that, we will then worry about LCD and all that nonsense. But right now, just multiply straight across and see what happens. So 2 times 5, 3 times 1. 2 times -9 is -18, right? Well, actually, we did say we should not multiply. We should reduce first. So, and I'm seeing all along the way, things may reduce. So let's hold off on multiplying the numbers. These were all prime, so I just went ahead and did it. It was never going to reduce. These will. Okay. But if you can't see it, then we should always not multiply right away. So we have the 2 and the 9 right here. The 3 and the 2. I put the minus in the front. 2 times a negative is going to be negative, so I put it here. But if that's weird, you can keep the negative inside if you want to. Once you're comfortable with skipping steps, you're welcome to do that. I don't care if you skip minor steps, just make sure you show some steps so I can grade your work. So I'm gonna leave it here. Okay. I'm just gonna put them right next to each other, like we did when we did the fraction review. 13 times 1 is just going to be 13. I'm going to leave it as is, 13. Okay. So at this point, start breaking things down and see what you can cancel. I know I'm showing extra steps that you might not need, but it's unfair for me to skip steps. So we got -9, which would be -3 times 3 over 3 times 2. So we see that these 3's will cancel and these 2's will cancel. So now I'm sure I don't have to worry about reducing. This guy, 13 goes in 39 3 times, right? So that's actually 3 times 13. And you can always separate the x if you want to. It doesn't make a difference, but if this feels better, feel free to do it. And the last one will be -3. It's already broken up. Nothing cancels, right? So I say we just go ahead and leave it as is. Yeah. We'll worry about that later. Okay. So now I have 10x over 3. That one didn't change. Plus a -3. Or you could do -3, right? Same thing. Over here, these guys canceled, leaving me with -3 times 3 times x, which is a, yeah, no, consistency. -9x. None of this canceled. This is just how it is. So that would be minus plus a -3 over 13 times 7. Yeah, I was gonna leave it like that. It looks ugly. Pen's running out. Anyway, so everything is reduced. Everything is multiplied. So the hard part is done. So before we go any further, is there any questions on how we distributed? And why we factored stuff out? I'm sorry, I factored the numbers. Okay, at this point, you would just combine like terms, but it's going to require fractions. So these are like terms and these are like terms. So let's go ahead. I don't know if I have enough space to do it here. I'm going to turn the page in just a moment. Okay, turn the page then. So I'm going to rewrite that last line.
And Mr. G, 13 times 7 will be 91.
You which one? Sorry.
13 times 7 will be 91.
Okay. We'll use that in just a moment. Okay, so I'm gonna keep it like this just because it is easier to see the LCD like that, because we're gonna have to factor it anyway. But first is group everything together. So this one's a little more challenging because it has fractions in it and it requires you to do your LCD step. You said it was 91, right?
Yes, sir.
I'll leave it in there for now. So we can combine these two and those two. So remember when we said to find the LCD, take every fraction and see if it's already prime. These are ones, so we don't have to worry about those. And 91 was originally 13 times 7. So we said look at every factor and start with the smallest one. 13 is the smallest. It appears once here and once, and that's it. Doesn't appear anywhere else. So LCD will contain 1 3 only. We go to the next number, 7. 7 appears once in this location and not and 0 times over here, so only 1 7. Remember, it's the most number they appear in one factor, in one location, not the total. Then go to 13, there's 1 13 there, no 13s here, so let's multiply these numbers together. So that's gonna be what, 91 times 3, right? $273, right? Okay, so now look at every single fraction and figure out what do I need to multiply it by in order to get 273. So it already has a 3. So we're going to need 7 times 13. We're going to need these two. In other words, so multiply by 91 over 91 minus 9x over 1 multiplied by 273 over 273. That's horrible. Minus 3 over 1 times 273 over 273 minus 3 over 91 times 91 is missing a 3, so there's 3 over 3. Or my neighbor's cutting their grass or something. Forgive me. Okay, so 91 times 10, let's multiply straight across. That's going to be 910x over 273 minus 9 times 273. I don't know what that is. Let's see. $24.57. Okay. 3 times 273. $819. Minus 9 over 273. Okay, so this one's really testing our fraction skills, right? So 910x minus 2457. Okay. 910 minus 2457. Negative 1547. subtract those guys. Negative 819. When you're using this calculator, make sure you use this symbol down here for negatives. Don't use minus for negatives. It'll have an error. You can use minus for the next part, but not for the first part. Okay. Let me double check some stuff. It looks like this reduces seven goes into, well, we know that 273 is made out of 3 times 7 times 13. So one way to reduce is to divide the top part by each of these and see if it reduces. Since it's kind of large, it's a little difficult to see. So I would just say take 1547, divide by 3 and see if you get a whole number. I did not. Divide by 7 and we do. So that's 221. So both are divisible by 7. So I'm going to get negative 221x over 91. No, actually, 39. Now let's check this guy. $13 goes into both of them. So 221 divided by 13 is 17. That would become negative 17x over 3. Oh, wait, hold on. Yes. So we reduce this first part. Now let's go ahead and check this guy. So write 828 on your calculator and divide by each factor. Does 3 work? It does. Divide both by 3, we will get, the calculator, we got 276 over 273 divided by 3 will be 91. Now does that divide further? 276 divisible by 7? Nope. 276, is that divisible by, let's see if I can get it out there. By 13. Nope. I think that's it. Oh, 3 works. Yeah, 3 works. Okay. So 3 makes it reduce to 92. Over 21. Let me double check. No, that's a lie. That is fake math. One moment, let me double check this first step here. Yeah, it just stays like that. Anyway, depending on what they're asking for, simplifying it all the way would be, if you keep them separate, would be like this. Or if you were to combine them into one fraction, you could have it this way.
Mr. G, can't you, doesn't 276 over 91, can't that break down one more time.
Let's see. By what number?
276 divided by 3.
Does it go 3 going to 91?
No, it doesn't.
Yeah, we can. Yeah, I thought the same thing earlier. I wanted 3 to work, but it didn't. Yeah, this is as pretty as it's gonna get. This one's this one was a little more challenging. I won't put that on a test, okay? Don't worry. But it's a good homework question. It's good for practice because it forces you to do all kinds of things. So it sums up the entire section. But don't stress yourself. Just make sure you remember LCD. Make sure you know how to add, subtract fractions. And you should be okay. If you have any questions at the beginning, middle, or end, this one was a long one. I don't think we have time for 2.3 or 2.1. Okay. You have any questions? So today we went over simple. I didn't like the terms. Excuse me. Plugging in numbers into variables. We talked about coefficients, distributing, multiplying by negatives, and then multiplying by fractions. Do you have any questions on these ideas?
No.
Right.
Sorry.
Let's just start make sure you start working on chapter 1. I don't think I've put any due dates yet, but I will very soon. That's on my to-do list, but next time I see you on Tuesday, we'll start chapter 2. So bring some questions if you have any, and if not, we're just gonna go ahead and start 2.1, okay?
Mr. G, are we still doing remotely or are we meeting on campus?
Oh, right. I don't know if you guys got that text message or not, but we're staying one more week on remote. So next week will be remote, and then after that, we'll be back on campus. So we return to campus on the 7th of February.
Yes, sir.
All right, guys. Well, we'll see you Tuesday via remote.
Hello, how can I help you?
Mr. G, have a great weekend.
You too.
Good weekend.